going to focus on quadratics. And we're going to focus on three major forms of them. What we'll talk about is there's the standard form. Okay, and the standard form is usually, it's pretty commonly written like this. Y, actually let's make that color black there. We have y is equal to a x squared plus b at x plus, and then usually this is a c. Okay, so this is known as your standard form. We also have a factored form, and that one is commonly written as y is equal to, and we'll talk about it as we're going, a again. So you'll notice there's an a term in both of those, and that means that value is always the same. The other two are a little different. They have an x minus something and an x minus something. Depending on your teacher and how it's taught, the variables will range. They might call it an r, an s, a t, a d. That changes per teacher. But essentially what it means is it just represents some value, and those values are known as roots, actually. They're technically the x-intercepts of something. And then finally, we have vertex form. And vertex form, from its name, kind of tells you how it helps you, is it helps you actually find the vertex of a quadratic really simply. Again, that a value is there, and that's important. There is an a in all of them, which means that number is the exact same no matter what form we go between. X minus h squared plus, and then let's make that a better plus. Finally, the letter k here, okay? These are your three major forms of a quadratic, and when we talk about a quadratic, we're essentially saying, can I draw a line nicely here? No, it doesn't look like it. Oh yeah, I can. Here we go. When we're on our Cartesian plane here, our quadratic looks something like this, let's say. Here could be one of them, or it could look like this. And I'm actually going to make it a little wider, because what I'm going to try to do is I'm going to try to... oh, it erases all of it. That's good to know. I want to show how each of the forms gives you a little bit of graphical information that you may not have got before. So actually, I'll just draw one large one. Okay? And what's going to be important here is in your standard form actually kind of gives you the least amount of graphical information. The c value is actually what the y-intercept is. Okay? So this would be known as c, or as the y-intercept.
Yeah.
Okay? So standard form, that's the only piece it gives you. The a and b value aren't so wonderful, and we'll go into Desmos and we'll talk about those in a minute or two, but let's talk about the other major forms. We have factor form too. Factor form gives us a little more information. The r and the s, these are actually your x-intercepts, okay? So you might call that r, you call that s, and these are your, sometimes known as roots, okay? I can't write outside there, okay? Or x-intercepts. See if I can fit it all in. Great. And then finally, your vertex form, the h and the k value are really important. They tell you exactly what the vertex happens to be. I guess maybe we'll use a different color here. We'll use red. Okay. And we'll draw an arrow to it just to help us out a bit. But the x value of the vertex, so I'm going to write it like a coordinate. X value of vertex and y value of vertex are actually the h and the k value. Okay, so they're the exact value. So each of these forms gives you a little more graphical information. And when you're doing any type of rough sketch of a quadratic, if you have these four major points of it, and they don't all always exist, you'll always have some vertex. You'll always have some y-intercept. You may not always have x-intercepts. Okay, which means there may not be like a factor form that you can kind of use, okay, at least with the r and the s values. And what ends up happening is you have a standard form that kind of doubles as a factor form. An example of something like that would just be like a quadratic. Let's see if you can see yellow here. That's not bad. Something like that where the vertex is above the x-axis here, and it opens upwards. So if it opens upwards and the vertex is above, that means it never crosses the x-intercept, therefore has no roots. And the other possible version of this is the vertex is below and it opens downwards, you'll have no roots. Because they go left and right forever, a quadratic, you will intercept the y-intercept somewhere. It could be an extremely large number, very close to like an infinite value, that or might seem like an infinite value to you, but it does cross that. Okay, it's the x-intercepts that we want to have, and a quadratic always has some turning point known as the vertex. So keep that in mind. But what we really I want to kind of focus on is that we move between these forms when we're gathering different parts of pieces of information, and we use different names of what it is we're going to do. So let's see if I can type it in here. When you go from standard to factor form, you factor. Let's see. Oh, that didn't turn out so well. Factor. Okay. Can I turn it? Oh, I can. Look at that. How convenient. I erased it. Brutal. Let's try that one more time. Factor. I don't know how to keep it. I apologize. We want it over here. I duplicated it. Good enough. Okay. We go from factoring. So when you're going from the standard to the factored form, you're going through factoring. So we'll call that going down this way, okay? But when you go from factored to standard form, we're actually using what's known as the opposite of that, and it's called distributive or expanding. Expanding or distributive. Distributive property. Okay? And hopefully those are somewhat familiar too, because those are the ones I know that you guys were going to focus on. Whoops, I wanted to turn it actually. Then duplicate it. Okay. This one, let's delete it. And this one will move over. So when you're going the other way, we use distributive property. And all that is taking the factored form and multiplying. So sometimes they call it FOIL or binomial distribution or a rainbow method, where you multiply all the terms in the brackets and then you finally multiply your a value and you'll get to your standard form. And the opposite of that is taking the standard form and factoring to go back. We can talk about these ones here, but I know that you had a focus on these, so we'll probably just focus on these ones to start. I'll mention the other versions of this. Technically, another way to do from standard to factor form is something called the quadratic formula. And we might get into that a little later, but keep that in mind. It's the same concept as factoring. It's just using a formula to do it rather than some shortcuts. Standard to vertex form, there are formulas for it. Another version or a way to do it is called completing the square. So we take the standard form, we turn it into vertex form. And from vertex to standard, we expand our distributive property. So the exact same one. So you go back that way. And then finally, from factor to vertex, sometimes what you do for factors is you find the axis of symmetry and then plug in a value, or in vertex you're going to isolate for the x value. So they don't have really formal names, but they're processes that we use. So we can move between all of these. Like I said, we're going to focus on these two to start, so we'll work with those two and we'll bring up a couple examples. In fact, maybe we can jump to a second page here and let's move that. Add another page. Okay, let's give a little example of what this could be. So we'll use a distributive property here. What we're going to do is we're going to start actually in our factored form. So let's say we have a factored form here. And it says this: y is equal to 3x minus 2x plus 1. Okay? So this is in factored form. So we're going to use what we call that distributive property. To move to our standard form, okay? And I'm not sure what they would have called it in your class. Sometimes, have you heard the term FOIL before?
Yeah.
Yeah? Okay. So all that stands for is the first terms, the outside terms, the inside terms, and the last terms, okay? And when they say that, for instance, let's do in red first terms. First terms just means we're going to multiply the two first terms in each of the brackets. So in English, we read left to right. So we consider the term farthest to the left in each bracket the first term. So in the next line, we might read y is equal to, we still have 3, but this time when we have x times x, we have x squared in that case. The next thing we're going to do is the outside terms. And outside terms refers to the leftmost term in the first bracket and the rightmost term in the second bracket. In this case, we have x times positive 1, so we get positive x. Okay, so we've checked off first and outside. The next thing we might do is the inside terms, and that is the rightmost in the first bracket and the leftmost, the two towards the middle. Okay, so we're going to multiply these two terms. Negative 2 times x gives us negative 2x. And then finally, we deal with the last terms, and those are the two terms farthest to the right in each bracket. So negative 2 times positive 1 gives us negative 2 in this case. Okay, and what you will notice, sometimes they'll have like a rainbow method, is that you've taken the first term and you've multiplied it by both, and you've taken the second term and you've multiplied that by both. And that's going to be pretty important for what we're doing here, okay? So just to give you an idea of that again, we took this and we multiplied it by both these terms, and then we took the second term and multiplied it by both of those terms, okay? So that's going to be helpful for what we've done. We're going to collect the like terms within the bracket, and then from there we're going to finally do one last distributive property of the 3. So we're still going to leave that 3 on the outside. We'll collect whatever like terms. Because this is x squared, there is no other power of 2 variable. We leave it. We have x, or positive 1x, and negative 2x. So think of that as taking positive 1 minus 2, and we're going to keep the variable attached to it because they're both technically to the power of 1. So positive 1 minus 2 will actually give us a negative 1x. And we don't usually include the 1, so I'm just going to say negative x in this case. And then finally, we have negative 2. So we've collected the terms here. The last thing we got to do is, again, another set of distributive property. But because there are 3 terms, we have to multiply the first term by all 3 of them. Okay? So when we do that, we get y is equal to 3x squared minus 3x, and then minus 6, okay? And this is our standard form. So we've gone through that process. We've gone through that process of using distributive property. With that being said, we can do the reverse, okay? Let's take this exact same equation we have, y, oops, I don't want it to be red. Okay. We're going to take this exact same equation. So y is equal to 3x squared minus 3x minus 6. Okay. And we're going to turn it into factor form by factoring. Okay. So we're going to use that factoring that we talked about before. Now, there's many different types of factoring. A common one is called sum and product. So SNP, let's call it SNP, sum and product. And that's where you would take the A value times the C value. So A, you're looking for A times C. So you're looking for a number that A times C is equal to, and that adds up. So put it over here. No, I'm going to put it here. Two terms that also add up to that. So for instance, A times C in this case, we need two factors that equal A times C. And because in this case we have 3 times negative 6, that actually gives us negative 18, okay? So we need two numbers that also multiply to this negative 18 and add to our B term. And our B term in this case, I've kind of written this funny. I'm going to try to clean it up a little for you. Let's put the B there. And the B term in this case is negative 3. So we want two terms that add to it. And in this case, this is the B term. So what does B equal to? Okay. So this is how we got to this information. We took A times C. So this is the A value. This is the C value. We multiplied it and we got to negative 18. So we're going to look for two factors of negative 18. Also, it says, what's the B value? Well, the B value in this case is negative 3. We need two, what's the term? Values. two values that sum. There should be a term for them. I don't remember the name off the top of my head. They're not factors. But two numbers that add up to -3. And those two same numbers have to multiply to -18. So if we think about it, I can tell you two pretty quickly off the top of my head that I think are going to work. 6 and 3 have a difference of about 3, so they'll probably work. So I'm going to say 6 times 3. One of these is going to have to be negative. If I made the 3 negative, then it would be +3. So I'm actually going to make the 6 negative. -6 plus 3. -6 plus 3 gives us -3, and -6 times 3 gives us -18. So in this sum and product, we do some decomposition. That's another term for this. And what we're going to do is we're going to decompose this middle term. And essentially what we're saying is we can take -6x and plus 3x, and that we're going to split this term into those two values. And I'll kind of explain what I'm doing as we go through it here. Y is equal to 3x, smaller line, let's make that bigger, squared, and -6. Those will stay the same. But what's happening here with these values is I can say -6x and +3x. So if you look at these two terms, if we were to combine them, because they are like terms, they end up equaling -3x. So we haven't changed anything in the equation. We've changed the terms themselves, but what the equation is equal to is the exact same. So in this case, -6x plus 3x equals -3. So we've decomposed it. We've split it into two terms. The reason we do that is because now what we're going to do is we're going to find common factors between the terms and factor them out to get back to our standard form, okay? I know I've left myself with a very small amount of space here. So we'll try to see if we can continue here. Draw a line. So y is equal to, we're going to look for a common factor here. So if we take a look at the two coefficients, we have 3 and 6. 3 is a common factor, and also we have an x. So I can actually take out 3x in this case. When I take out 3x, this becomes 3x squared, and think of it like it's divided by 3x. So now because we common factored, we got to divide both of these by 3x. So this is where our 3x went. Okay. When we do that, 3x squared divided by 3x just leaves us with actually just x. And -6x divide 3x leaves us at -2. Okay. Over here, same concept, we need to common factor out a value. It looks like only 3 is going to come out of here. So we're going to divide both of these by 3. And it's going to be a positive value, so we're going to say +3. And we're going to try to squeeze it in the brackets here. 3x divided by 3 just gives you x, and -6 divided by 3 gives you -2. Kind of fit it in there. Now what's happened is these brackets are the same. We have x minus 2 and x minus 2. That means we can actually common factor x minus 2. So we're going to divide this entire equation, or both of these two terms here, by x minus 2. The easiest way to think about this is just take these two brackets and you turn it into 1 here. And it's going to be multiplied by another set of brackets. And the other set of brackets will be filled with the common factors from those two brackets. So we're now going to take 3x and +3. Okay? This is really close to our factored form. If you notice, we have x minus 2. Hey, I have x minus 2. The only thing is I have x plus 1. In here I have 3x plus 3. What happened is they've actually common factored out the value of 3 again from this bracket, and that's how they end up with this a term. Okay? So we get y is equal to 3x minus 2. And when you divide both of those terms by 3, you get x plus 1. This is the exact same thing as that we've had here. So you can see these are just for moving back and forth between our different